Hello everyone. In this video, let's discuss how to write a program to validate binary search tree. Given the root of a binary tree, determine if it is a valid binary search tree. A valid binary search tree is defined as follows. The left subtree of a node contains only nodes with keys less than the nodes key. The right subtree of a node contains only nodes with keys greater than the nodes key. Both the left and right subtree must also be a binary search tree. Let's take an example one. So according to binary search tree, the left subtree should be smaller than the root and the right subtree should be greater than the root. So it satisfies the binary search tree condition. So I can say that this is a valid binary search tree. I am returning the output as true. Let's take the second example. Here I have a tree. So left subtree is smaller than the root. Fine. When I go for the right subtree, that is smaller than the root. According to the binary search tree, right subtree should be greater than the root. So this is not a valid binary search tree. I have to return it as false. Now let's discuss the logic in detail. Okay. So let's take a method. So first I have to take a method called public boolean is valid BST. So I'm checking whether it's a valid BST or not. Tree node root. So here I'm calling a method. So while calling a method, I'm going to pass 3 arguments. So whatever the method is returning, that has to be returned. Return. The method name I'm going to give is BST. I'll give. Here I'm going to pass 3 arguments. That is root and then the smallest value in an integer. That is long dot min underscore value. And the maximum value I'm going to pass. So long dot max underscore value. Okay. So here I have called a method called isBST. So the method has to return true or false. So I'll give the return type as boolean. Public boolean isBST. Here I have passed 3 arguments, which is tree node root comma int long, because I have passed long, right? So long min comma long max. I have passed 3 arguments. Now I have to check the base condition. So what is the base condition? If root is equal to null, I have to return true, because I can say that it is a valid binary search tree. So return true. Fine. So if it is not getting satisfied, I have to check the remaining case. That is, if root dot val is less than or equal to the minimum value, or root dot val is greater than or equal to max value. If it satisfies any one of the conditions, we can say that this is not a valid binary search tree. So I can return false. So to check whether it's a valid binary search tree or not, I have to call left recursive call and right recursive call. For that, return is BST. So for left recursive call, root dot left. For minimum, I have to pass the actual minimum value. For maximum value, I'm going to pass the root's value. Similarly, for right subtree, I'm going to call the recursive call, which is BST root dot right comma root dot val comma max. That's all. This is the logic of the program. Now let me trace and show you so that I can understand this very clearly. So here I am going to call a method called isBST. So while I am passing the method, I will be passing the root value as 100. Fine. This is my root value. So this is minimum, this is max. For minimum, we'll give long as minimum and long max. So in the data type long, what is the minimum value that will be initialized? In the data type long, what is the maximum value that will be initialized to the variable max? Now root equal to null. No, root is not equal to null. So I'll go to the next condition. Root dot val is 5. 5 less than or equal to minimum value. Actually 5 is not less than or equal to the minimum value. Check the next condition. 5 greater than or equal to maximum value. No, 5 is not the maximum value. I'll go to the recursive call. So first I'll go to the left recursive call. So here I'll be calling isBST. While I'm calling the recursive call, the root value will be passed as root dot left. Root dot left is 200. So 200 will be passed along with this. What is actual minimum value? So the minimum value is long min. Let's assume it to be long min. I'll give for our understanding. And for the maximum value, I'm going to pass the root's value. Root's value is 5. This I'll be passing. So here I will be calling left recursive call. Now currently root is present to the node called 200. Now check root equal to null. No, root is not equal to null. Check root dot val is less than or equal to minimum. Root dot val is 1. 1 less than or equal to minimum. No, 1 is not less than or equal to minimum. Check the next condition. 1 greater than or equal to 5. No, 1 is not greater than or equal to 5. So this condition is not true. I'll go here. I'll be calling the left recursive call. So when I try to call the left recursive call, I'll be calling the call is BST. Okay. So here I'll be passing root dot left. That is null will be passed. For minimum, the actual minimum value is long min. Okay. For maximum, I'll be passing the argument as 1 because root value is 1. So I'll be calling the recursive call is BST. Now check whether root is equal to null. Yes, root is equal to null. So I'll be returning true to this place. So here I'll be returning true. Okay. So here I'll be returning the value called true. Left subtree will return the value called true. Now I'll go for the right subtree. On the node 200, I have to call the right subtree. So for the right subtree is BST. For right subtree is null. Okay, null, comma. Here root dot value is 1. That will be considered as a minimum value. And actual maximum value is long max. Because on the node 200, the maximum value is 5, not long max. The maximum value is 5. So this 5 will be passed. Now check whether root is equal to null. Yes, root is equal to null. So I have to return true. So I will be returning true here. Fine. So left subtree returns true and right subtree also returns true for the node 200. Now true and true, it returns true. So which means this will return true here. So this node will return the value true to the left subtree 100, which means left subtree is a binary search tree. I have to go for the right subtree now. So when I go for the right subtree, I have to call the recursive call. Just for this method, right recursive call I have to call is BST. So right recursive call root dot right. Root is 100. 100 dot right is 300. So 300 comma. Okay. For the node 100, actually for minimum value we have considered as long min. Maximum value is long max. That is what I have considered. Okay. So 300 I'll be passing as my root. Root dot val. Root dot val is 5. 5 will be considered as the minimum value and maximum value will be considered as long max. Fine. Now currently I am standing on the node called 300. Now check whether root is equal to null. No, root is not equal to null. I'll go here. Root dot val less than or equal to minimum. Root dot val is 4. 4 less than or equal to minimum. Yes, 4 is less than or equal to minimum. Condition true. So when the condition is true, we can say that this is not the actual binary search tree, because according to the binary search tree, the right subtree should be greater than the root. So here I have given the condition root dot val is less than or equal to minimum. Root dot val is 4. 4 less than or equal to 5, condition is true. So I can return false, saying that right subtree is not a binary search tree. So I will be returning the value false to here, which means for the method 300, which means address 300 will return me the value called false here. Just right recursive call return the value called false. For the node 100, left recursive call returns true, right recursive call returns false. True and false, it is false. So this method will return false, saying that the given binary tree is not a valid binary search tree. So I'll be printing my output value as false. That's all. This is the logic of the program. In case if it is a valid binary search tree, so left subtree also will be returning true, right subtree also will be returning true. True and true, the final output will be true. That will be returned to the place where I have called the method. So that will be returned true here, and this method will return true. Now let's try to implement it as a program. So I have to give return. I am going to call a method is BST. So here I am going to pass 3 arguments. What are the 3 arguments I am going to pass? Root, long dot, min value I have to pass first. Min underscore value, comma, long dot max underscore value. Fine. Now I have called the method called is BST. Let me define this method. Public boolean is BST tree node root comma long min comma long max, because the data type I have passed is long only. First we have to give the base condition. So what is the base condition I am going to give? If root is equal to null, I have to return true, saying that it is a valid binary search tree. Checking whether it is not a valid BST. For that I have to give the condition is root dot val is less than or equal to minimum, or root dot val is greater than or equal to max. If it satisfies any one of the condition, I can return false saying that it is not a valid binary search tree. Recursive call for left and right child. So first what I have to do, return is bst root dot left comma min comma root dot val and is bst root dot right comma root dot val comma max. That's all. Now let's run the code. Okay, there is an error. Okay, bst T should be in capital. Let's run the code once again. As it passes the test cases, let's submit the code. As it passes all the test cases. That's all.